Okay, this is an attempt at a little desktop science experiment using the TinySA Ultra as a signal source and the HackRF portapack in HackRF mode as a receiver. So on the left we'll be transmitting at from the TinySA Ultra at 2.445 gigahertz, and we'll be receiving that signal on the HackRF. We're going to be using whip antennas for this, so we have a whip antenna here on the left. That'll be the transmitting antenna, and what's it, maybe 3 feet away we have a receiving whip antenna that'll be connected to the HackRF. It's connected to the HackRF, and I have a script or a flowchart in GNU Radio Companion, very simple, that is set up to receive the signal and display it on an FFT. And the purpose of the experiment is to use this metal plate as a reflector. And I'm going to be putting that plate behind into the side of the transmitting antenna, kind of at a 45-degree angle, so that it'll reflect the signal over to the receiving antenna. And if I get the position just right, there'll be destructive interference and we will see the waveform decline on the FFT in GNU Radio Companion. So the first thing I'm going to do is turn on the output signal source, and come over here. I'm going to basically set up the camera to watch the FFT in GNU Radio Companion. So I'll start that. It's set up for a center frequency of 2.44 gigahertz right here. That's the center. And this is the 2.445 signal from the TinySA. I'll turn that on and off so you can see. Okay, there's the signal turned off from the TinySA Ultra, and now I'll turn it back on, and you see it rise up. All right, so you're not going to see me move the plate around, but I'm going to try and do that. And if I move it just right, and in the just right position, I can get that signal to be attenuated or canceled out through destructive interference. And see what I can do here. A little bit tricky. There we go. I'm about a wavelength away from the antenna now, which is about 5 inches, or there we go. There you see the signal declined. And then if I move the plate in the other direction, the signal will come back up. Alrighty, Vertasium has a pretty neat video explaining this with water waves. Let me just play that for a minute.
I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference, and there's basically no wave there.
So that was the idea of this experiment. When I move this plate in the area of the, excuse me here, under this plate in the area of the transmitting antenna, we get a reflected signal. So we basically have two sources of the RF waves, and those are then they move through space to the receiving antenna. And if I put that plate in just the right place and get the reflected wave to be out of phase just right, it basically causes a decline in the received signal strength. So that was the point of this video, and I thank you for watching.